Welcome to your latest video in your Design of Experiments course. And in this video, what we're going to do, we're going to have a little summary of what we've looked at so far, and then we're going to relate it to what the rest of the course is going to look like with the software. So let's just summarize where we've gone to so far. So some key points. Number one, we've talked about the limitations of one factor at a time. How one factor at a time gets you less information slower. Okay, so we've talked about that. Number two, of course, the replacement is the idea of a balanced pattern. And from the balanced pattern, we have two potential experimental techniques. We can screen or we can model. Okay, so we can go screening, we can go modeling. Now, we've practiced screening with the catapult exercise. You've identified, just using marginal mean graphs only, 3 variables that will shift the mean and 1 variable that will reduce the variability, reduce the standard deviation. So you've done a screening DOE. Our weapon of choice is an L12. We have practiced a modeling DOE. Now, modeling DOEs are typically full factorials. Now, we've practiced a 2 by 2, 2 variables at 2 levels, and you've done a little hand calculation and seen how the computer would do that analysis. Now, just the last thing, I suppose, 3, we are concentrating on 2-level experiments. Okay, so they're the experiments we're going to major on for the majority of the course. Now look, if you get good at the techniques here, you will effectively be learning techniques that can take you to 3-level experiments, etc. So we're not wasting our time or missing knowledge. You're just learning on the simpler experiments to get good at what you're doing, and then we can explode into the other techniques. Okay, so we're only doing 2-level. What does 2-level mean? Well, it just means you're testing high and low, and we are assuming that the relationship between the input variable and the output response is a straight line. If that's not true, that it was really a curve, then ultimately we're going to have to turn that 2-level into 3-level. But we don't do that until we see that knowledge. If we see this knowledge, we'll do this. Until we get the knowledge, we assume the red line. Okay, so 1 factor at a time, terrible method. Balanced patterns, the most efficient way to get the most information. 2 types of balanced pattern, 2 types of, effectively this is the heart of design of experiments. Screening, modeling, and we are going to major on the 2-level experiments. Now, what I'm just going to introduce to you now for the rest of the video is the menu. The balanced pattern menu that we are going to practice. You've already practiced the L12, you've already seen a full factorial. So you've seen a little bit about what we're going to do, but now I'm going to show you the full menu of what we're going to practice. Okay, so that full menu looks like this. If you have 2 variables, we will do a 2-level, 2-factor, 4-run experiment, a full factorial. This is a full factorial. If you have 3 variables, we'll double that first experiment up. We'll go 2 to the 3. It becomes an 8-run experiment. Once again, what is it? Full factorial. These are modeling DOEs. If you have 4 variables, 4 dials, 4 things you want to test, what are we going to do? A full factorial. 2 to the 4. 16 run. Now when we get to 5 variables, we are still going to recommend a modeling DOE, but we're going to try and save some time. We are going to do the half fraction. So not a full factorial, which of course would be 32 runs here. It's known as the 2 to the 5 minus 1, 16 run. Again though, we are modeling. Now when we reach that point, that is the end of the modeling list. So modeling with small numbers of variables, that's what you're going to learn. Once we've gone larger numbers of variables, 6 all the way to 11 variables, we are therefore screening. So this is where we start to screen. And that then becomes the Taguchi L12. How many runs? 12 runs. And that's the menu I'm going to teach you. So you can go up to 11 variables with the experiments that I'm showing you. Now look, this is base camp for DOE. You learn to do this, all of the things become possible. Can I screen more variables than 11? Yes, I can. You bet I can. Would I recommend it to you? No, I wouldn't. But it's not to say there aren't experiments out there. There is a Taguchi. I think it's an L49 or it might be an L48. It will screen 47 variables. You want to go do one of those? Knock yourselves out, but don't ask me to help. Too complicated, way too complicated. So this is a great place to be. Most of your problems can be solved with this. Now, one last thing before we just take a quick look at the computer and what the software's doing with this exact menu. I want to talk to you about sample size. Okay, so look. When you do a 4-run experiment, the software is going to ask you for 9 repeats. 9 times 4, sample size of 36. All right, so within the 30 to 50 window, very important. But when the DOE doubles, the repeats comes in, and now it only asks you for 5 repeats. Times 8, 40 data points. So look, we've doubled the experimental complexity. We've only increased the sample size by 4 pieces. Next one, 16 run. We only want 3 repeats. Times 16, which is 48 pieces. So you can see, look, the sample size is staying in the window. 30 to 50. Obviously the next one down is also a 16-run experiment, so it's 48 pieces. And finally the L12 is 4 repeats times 12, 48 pieces. So whenever you do this, so think about this. I can get knowledge on 11 variables with just 48 samples. divided through, it's just 4 samples per lever. When people say, is there a fast way? Yeah, there's the fast way. And there is no faster way to do this. If you go below that, less sample size, less tests, etc., you're not being clever, you're not being more efficient, you're being half-arsed and you're getting it wrong. This is the shortcut. There is no shorter way to do it. And you know, if you multiply the combinations up, if you've got 11 variables, all with 10 positions, what would that be? That would be 100 million ways of setting that system up, and we just want to test 12 of those 100 million. That's the shortcut. I can't give you a shorter cut. Okay, so that's the menu. Now let's take a look at the software, and I'll show you where the menu appears on DOE Pro. Okay, so within Excel, I've got Excel open. I've clicked on DOE Pro, which has brought the Sigma Zone menu item into the ribbon. If I click on Sigma Zone, there is DOE Pro waiting for me. And the place we want to go is Create Design. Now when I drop Create Design down like that, I get a list: computer aided, non-computer aided, fractional factorials. We will come back to fractional factorials a little bit later, but let's take a look at the computer aided list first of all. Now straight away, it goes straight to that menu that I've just put on the board. And so it only gives you one choice for each situation that you're in. So if you say to the computer, I have 4 factors, 4 levers that I wish to interrogate and understand, well, the list says, well, if you've got 4 factors, you're going to run a full factorial. There are no choices. That's the best way to start off design of experiments in your building your skill and understanding of it. So there's the menu. There is also a menu, look, if you wanted to go 3 level, and that's very similar. You know, there's just one choice in each situation, okay? So that's the computer aided list. But if I quit out of that and I go back and go non-computer aided, now what do I get? Well, now you get no advice. It just tells you what the DOE is. And the computer is assuming you know what you can use this thing for. So, you know, a 32 run half factorial doesn't tell you how many factors is in it. You know, it's up to you to use it to the best of its ability. Look at the Taguchi designs: L4, L8, L12, L16, L32, Plackett and Berman designs all the way up to a 28 run DOE. Now that's a 28 run screening DOE where you could screen 27 variables if you wanted to. So you can see there is an alternative list out there, but let's get good at the computer aided list first. Let's build your skill, and then we'll go and play if we really want to, because what you'll probably learn, and certainly I've learned this, in 25 years, I rarely step off that menu. It really does work brilliantly. Okay, so there's the software doing its job, okay? So it's directing you to the computer aided list. This is the list that we're going to cover in the course from now on. We're going to do exercises where you practice. What we're also going to do is add some bells and whistles. I'm going to show you how to do robust design using a special Taguchi method. I'm going to show you how you do robust design using interactions and interaction plots. So what we're going to do is take a basic set of DOEs and we're going to show you their absolute possibilities. And their absolute possibilities is fantastic. And then what I want you to do is get good at this, and I want you to learn how to use this menu of experiments in your career, and you're going to become a highly powerful researcher or a highly powerful engineer, because you are going to have the best tools at your disposal. So that's what we're about to teach you. Now in the next video, we're going to show you how to plan for one of these things. So one of the most crucial things of the DOE course is how to properly plan an experiment. And that's in the next video. Now the next video is going to be a little bit lengthy, possibly 40-50 minutes. So what I want to make sure is when you go to the planning video, you got plenty of time, because planning is the bit. I can teach you all the theory, but the planning is a practical day. You spend one day with your team planning your experiment so that you make sure that when you do the experiment of choice, it goes off perfectly, you get fantastic knowledge, and you move your process knowledge forward in huge leaps and bounds. I will see you in the next video.